we have a compound interest problem, and it's asking how long, so we're solving for time. You do need to have memorized this compound interest formula, 1 plus r over n to the nt power. $800 is being invested for an output of 2,000, so A is going to equal 2,000 and P will be 800. We're going to have 1 plus, the interest rate is 4.3%, so 0.043 divided by 365, because we do have the word daily in the problem, all raised to the 365t. The first thing I want to do is divide each side by 800, and it turns out that that goes in 2.5 times, so we will have 2.5 is equal to this expression, 1 plus 0.043 divided by 365, all raised to the 365t power. Now notice how the t is in the exponent position. That tells us we need to log each side. So on the left we're going to have the log of 2.5, and on the right the 365t is going to come down, and then we will have the log of that expression that is inside the parentheses there. At which point we want to solve for t. And t has been multiplied by the 365 and that log, so we want to divide each of those off. We will then have the log of 2.5 divided by 365 times the log of this expression is equal to t. Now, a common mistake that people make with their calculators is they forget that there is an extra parentheses around the denominator because you've got 365 times that log. And when you do that on your calculator, you should get out a value approximately 21.31 years. For number 10, we're being asked to find and graph the inverse. Now let's start with this function itself. It's a parabola. It's going to have its vertex 1 unit below the origin, as I've plotted way down at the bottom of the screen there. The 3 in front of the x squared tells us it's going to open upward and be steep with what I called a kind of slope of 3. So this right here is going to be our original function f of x. Now we need to find and graph the inverse. Well, we know what the graph of the inverse is going to look like already. If 0, -1 is on f of x, -1, 0, which I'm plotting here, is going to be on its inverse. If the graph of f goes through -1, +2, our other graph is going to go through +2, -1, and it turns out +2, +1 also, and the graph of the inverse will look like this over here to the right. Notice how this inverse is not a function either, because it does not pass the vertical line test. Instead, it is a relation, but we cannot use the notation f inverse of x. Now, to find the equation here, we're going to have to start with y equals 3x squared minus 1 and switch the x and y. When you switch the x and y, you have x is equal to 3y squared minus 1, and then you want to solve for this new y value. Let's add 1 to each side, and then divide each side by 3, so we'll have x plus 1 over 3 is equal to y squared. When you square root both sides, moving down here, we'll have plus or minus the square root of x plus 1 over 3 is equal to y. It turns out that the plus and minus are going to refer to the upper half and bottom half of the sideways parabola separately. Now let's simplify this logarithm. I don't like that big 6th root there, so I'm going to rewrite this as log of the whole xy squared over z to the 1/6 power. And then I can use properties of exponents to bring that 1/6 down in front. That gives me 1/6 log of this xy squared over z. Then what I'm going to do is take this and split up the multiplication and division. I will have 1/6 times log of x plus log of y squared minus the log of z. Then I can use the property of exponents to bring that square down. That gives me 1/6 of log base x plus 2 log of y minus log of z. Then I can distribute that 1/6 through and get 1/6 log of x plus 2/6, which reduces to 1/3 log of y minus 1/6 log of z. Now we've got separate simplified logarithms. This next problem asks us to simplify, and the easiest way to do this is to say 3, the base, to the power is equal to 1/27th. And that turns out to be 3 to the -3rd power makes 1/27th, and we can get our answer that way. A second way we could do this is to say, let's set this equal to x and say 3 to the x is equal to 1/27th, and then solve that equation either by writing the right-hand side as 3 to the -3rd and setting the exponents equal, or logging both sides and using the procedure we've done before. On number 13, we've got a log base 5, and we have to use the change of base formula, which basically says this is equal to the log of 75 divided by the log of 5. That's the exact value. Now, approximating it on a calculator, we get 2.6826. Please check that work. This next problem says solve this exponential equation, and x is trapped in the exponents. We need to log each side. Because there's an e in the problem, I'm going to take the natural log of each side. That gives me 3x natural logs of e is equal to the natural log of 17. Now, there is an understood base of e there, and so this expression, natural log of e, is basically equal to 1, because anytime the base and the argument are the same, that's equal to 1. This basically now reduces our problem to 3x is equal to the natural log of 17, and therefore x will equal the natural log of 17 divided by 3. On a calculator, this is approximately 0.9444.